start that recording now. HDMI, turn them both on.
Boom. That's the one I want. So
you have it here as well. That helps. Carl?
That helps.
It's here as well. Carl, turn around. It's here as well.
Yeah. Cheers. So move that over here. All right. Thank you. So, all right. So the claim is contributing to PETSc is easy. And we have connection. Now, well, of course, contributing to PETSc is easy. That's a bold statement. Now, I have yet to find a rigorous mathematical proof for that. But let's settle to something more easy, which is let's just prove it by empirical evidence. So that means what we're going to do is we're going to run a live demo. So that means during the next 25-something minutes, we're going to improve PETSc in some particular way through the usual pull request process we have in place. I mean, there's always the option of, if you have altered the code in some way, send a diff file and we will take care of it. But let's try to do it sort of the 2018 way of doing things, which may not be the most efficient, but at least it gives credit to those who do the hard work. So, all right. So, in order to do that, so what we have here is just an overview over the PETSc repository. And I'll say, yeah, you play around with it, you find something. Let's probably start with playing around with it. So here is sort of the demo. Let's make it a little larger so you can actually see something. So our demo. And now suppose we want to just have a look at, I don't know, what did Matt talk about? Matt talked about matrices, and there are so many matrix things. So let's have a look into the matrix examples. And now if you have a look here, there are tests and tutorials. Tutorials, we heard a tutorial. Let's have a look into the tests. And if we have a look here, oh, that's a lot of examples or tests. So, well, probably that's the first way of getting lost. No, there is an actually easy way to find out which test is doing what. So you can just grab for the help string. So let's grab for the help string. Of course, there's something missing. Let's see. So now we have the help string for each of the examples.
Don't you want to use git grep? It's faster.
Sure. I don't think it like makes a difference in this case. Okay. So anyway, we can sort of cycle through the tests, and then if you have a sharp eye, you might notice that here there are no help strings. So those are examples 183 and 184. So what's going on here? So we see, oh, there's a line break so the example of extracting an array of whatever. So there's an incorrect line break. So you want to have it something like this, so that you grab the string properly. And if we do the same, 184. Oh, example of inverting a block diagonal matrix. That should also be something like this. All right. So now that is fine. So if we go, so since we cloned the whole thing, we can have a look at the files changed. So those are the EX 183, 185, and since we're not overly rude, we make sure that our changes still compile. So 183 and 184. So that is fine. Okay. And the diff, well, okay, this is just, well, we removed the line breaks. Okay, so our demo user has now identified two ways of enhancing PETSc. now how is the demo user supposed to proceed? Well, so one way which is sort of a bit tricky is to just commit it on top of master, but as we will see later, that's sort of not the recommended workflow. So we will do the right thing. We start a new branch. That is so we call that branch demo PETSc fix test, fix help mat tests. So in that new branch, we commit whatever we have changed, and now the hardest part about committing something is writing the commit message. So let's say for mat we fixed line breaks in help strings. So let's save that. Well, and then we push the whole thing back to our Bitbucket repository, which I will show you how to create in just a bit. So there's a -u missing. So now that might look a bit like witchcraft, but don't be upset. There's a wiki that explains the whole thing. So, okay, so we have just pushed our branch, which actually fixes the whole thing, to Bitbucket. Now, so I mentioned Bitbucket. So we started off with just looking at the PETSc repository. So what I have not shown you in detail yet was so our demo user was very eager, and here if you add plus, there is actually a fork this repository, and our demo user forked the repository already, so this is where we contributed our branch, because by default any random user cannot just commit to the PETSc repository. So there was the fork, and in the fork we committed our changes. Now here, that is the forked repository, so it's nicely named PETSc 2018 demo. So how that works. That's a 2018 demo. And well, if we have a look at all the branches that are there, then we find, oh, there is the master branch, which is the master branch. But here is our demo PETSc fix help mat tests. That was set up just 2 minutes ago. So if we look here, then we see we have one commit with our message fixed line breaks and help strings, and the interesting thing is right up here, create pull request. And since we want to enhance PETSc within the next couple of minutes, we do that right now. So if you just click on create a pull request, then it will automatically link back to the original PETSc repository. That will give it, well, it will populate a title with, well, last commit usually. You can add a description. You can specify target repository, which is the PETSc repository, and we want to have that merged into the master branch, which is sort of the latest stable features that may not be in a release yet, but are scheduled for the next release. Okay, now that looks all fine. Now that down there, you see reviewers. Now, usually that's pre-populated by default, but there is a Barry Smith somewhere. No, it should be B Smith. Or maybe not. Oh, BF Smith. To make it even harder. Barry F. Ha! We found Barry. Then there is also a guy named Napley.
You don't want him reviewing stuff.
So, and we create a pull request. And that's sort of all you have to do from the user's perspective. So, yes, there's a question, Martha? Well, that is so since this is a fork, you can always do whatever you want in your fork later. So I mean, it's up to you. Even then, it doesn't really make a difference. So. All right, so sort of our demo user has done all the necessary things. Now, as you can see here from top line, so now this is the open commit, the open pull request on the PETSc repository. So for that, I switch over now. So now I change identity. So from being a demo user, I now switch over to being Karl. So now Karl is taking over. So we have the list of pull requests here in the PETSc repository. Yeah, and I just reloaded the page, and now there is on top here this very first thing, fixed line breaks and help strings. So demo PETSc, if I have a look at it. I see that just happened a minute ago. Let's see. So here we have changes. I see reviews is just Barry and not Matt, so we should report that to.
No, it's because I already approved it. That's why it's
Oh!
You just say-
Good. Okay, so let's wait for Barry to approve it. Usually there is some sort of short discussion stream, which maybe it's just like a status message, sort of, which says like integration pending or something. So what I would do, so this is sort of the secret stuff. So I would, as Karl, I just pull the branch into the PETSc repository. This is this magic line you don't need to worry about. So, which I hopefully have not. Hope I haven't. Yeah, okay. So, and I push that to the PETSc repository, 960. No, let's see. That's this H agent for the win. All right. Yes, so now the branch also lives in the PETSc repository, which is sort of the technical detail for us to sort of deal with the details. Now, question is what happens with the pull request. So apparently, our reviewer Matt has already approved it. Let's see whether Barry has approved it. Nope. Okay, but we can test it and wait for Barry to provide his approval. So so what happens next? So our branch master is supposed to have stable features. Now for that pull request, it's trivial to check that not everything will fall apart. But for other pieces of functionality, it might be harder to find out. And for that, we have a separate testing branch, which is called next, where first features are tested, and if those features are fine and not like blowing everything up, then they get merged to master because they're tested and verified that they are sufficiently stable. So, so now we're in next, make sure we have the latest updates. Oh. All right, so, and then we would merge our pull request 960 in here, merge branch into next, and in order to do that properly, also add a reference to the pull request, which is probably not needed in this case. So now everything is in next. Since it doesn't change the PETSc library code, I don't need to reconfigure and I don't need to build it in this case, but usually that's just what happens to make sure that at least it works on my laptop. If a pull request doesn't work on my laptop, there is no chance that it will make it into master straight away unless I do stupid things, which I hope is not the case. So, all right, and now the pull request has made it into next, and what I would write here is something like demo PETSc, thanks, your contributions are now in next. So, or something similar. So if you read that line, if you open up a pull request and you get that comment, that's actually a good thing. That means somebody has looked at your pull request and it's now being tested. Now, what does being tested mean? Being tested means we're not waiting for someone to scream that something doesn't work, but we have an extensive nightly test suite. And that extensive nightly test suite is somewhere here. So a dashboard for all PETSc testing. Let's make it a little larger. Yeah, so there are tests run each day, or twice each day, one for the branch next. This is where we have put our commit in. And then there are main and master, and then the next temp, which is just for Matt to cool down his commits, and then you can propagate it to next. Okay, so assume there was a nightly test in the last 5 minutes. Now we have looked at the nightly test output, and we see, oh, okay, it looks fine most of the way. So sort of green is good, as you can imagine. Something down there is not quite as it should be. So if you compile PETSc on Linux with C89, then there is some incomplete build, but that is not caused by our changes. And you're not going to debug that now. Okay, so assuming everything is green, which was the case a few hours ago, but now separate build was happening. So anyway, assuming everything is green, it means that with all the different configurations, so PETSc compiled on Linux, on macOS, on Windows with 64-bit integers, sometimes with GPUs, sometimes on KNLs, all those different configurations which are sufficiently widespread and sufficient use. So their things are okay, where we can sort of approve our pull request and be sufficiently confident that things are okay. So what I or anyone else of the PETSc devs would do is we merge the whole commit to the pull request to master. So in that case, it was even a fast forward, so it doesn't boot the whole thing. So, and now we can confidently state that well, we have a few minutes left and we have just improved, enhanced PETSc. So, and if you as a user, so if you, very approved. Of course, I checked that after I've merged to master. So, and if you, after reloading the page, we see that now here, Bitbucket correctly labels that as the pull request being merged. And of course, we're going to be nice. We say thank you to the demo PETSc user, and just make sure that the notification or that sort of the complete history is there. That's what like the demo PETSc has thanked himself. Okay. No, that has to stay. Okay, good. Demo PETSc is very happy about his own contributions. Okay. So as you can see, we basically created a separate branch just for the pull request. So as you can imagine, there's not just one pull request happening within 6 months, but there are like lots of them happening. So from the pull request number, which was 974, so we have pull requests coming in weekly, if not daily. So so if we move to the right window, so if we just just count the number of branches. Well, in that case, 1,300. There are a couple of old ones, but there are lots of branches in there. That's sort of the main message, which brings us back to the last couple of minutes. We're going to talk about what are all these branches in the repository good for. As an extra benefit, usually the best person to present that would be Barry. Now, Barry is sitting there, but I thought, well, we should keep the spirit of Barry somehow reflected in that presentation. So here on the lower right, we have some quotes, sort of just added in every once in a while. Consider it to be added wisdom, but don't take it too seriously, please. Okay, so what are all the branches in the repository good for? So, okay, the explanation is easy. Everything is in that graph. I give you like 5 seconds. You can just quickly read through it, and then we're finished. We could finish 5 minutes early, or let's probably decompose the whole thing into more manageable bits. So let's sort of reduce the whole thing to the bare minimum, which is like, okay, just maint. The branch maint is our latest release. Or release plus a bug fix. So maint is, if you remember what Matt said earlier, maint is the branch you want to track if you're just using PETSc for production purposes. So basically, that's the stablest flavor of PETSc you can have. Whereas master is including all the latest features that are considered stable by the developers and that are scheduled for the next release, but have not been released yet. So at some instance in time, so here thinking of master, it's time for release. So we call that release, release 1.0. So the master and maint are synchronized at this point. So whenever there's a release, master and maint coincide. Plus, whenever there's a release, whenever there's a release, at some point it's time to start new features. So here, development always starts from master, and all features are developed in separate feature branches. So if some performance optimizations are applied to vectors, it's a separate feature branch. If the network receives improvements, it's a separate feature branch. So you can imagine as there are features added, the number of branches increases. So there's a feature branch that there's a commit in that feature branch. And once the feature branch is considered ready, it gets merged to next. So next is the testing branch where we make sure things are okay before anything goes into master. Okay, so next get tested. We have seen the nightly builds. And if everything is okay in the nightly builds, as it was the case for our demo user pull request, the feature branch gets merged into master, and that's pretty much the point where the feature branch stops. So then once your features are in master, you usually start a new feature branch if you add something on top. Or as Václav asked, you sort of close your feature branch if you want. However, you cannot always be sure that everything is in good shape at that point because sometimes you miss something. So,
are your feature branches linearly contiguous, or do you have forced update on them? What's the policy?
So we can force update them. So it's not linear contiguous, but that depends on whether you are working with someone else on that feature branch.
Negotiable.
It's negotiable in that sense, yeah. So the usual model is that you own your own feature branch and you do whatever you want with it. As soon as it turns out that, there are others contributing, you stop force pushing your feature branches.
You don't do a rebased compacted and then rebase it onto the latest master and then send it off?
We sometimes ask for that in pull requests. But I mean, the idea is feature branches should not live for months. They should be like...
I admire your optimism.
Sure.
It depends on how extensive the feature is and how much it disturbs everything else.
Yes.
It could take a month to write them.
Yeah, I mean, you can have scenarios where you have feature branches branching off feature branches because that feature is already needed. Then it gets hairy, but that's sort of the unusual thing. I mean, it's sort of, it forces you to think about the granularity of your changes. I mean, you're not trying to like just go wild on everything, but you at least, it encourages you to keep your changes sort of in a reasonable size so that others can also review it if needed. Sometimes that's not possible, yes, and those are the complicated cases. But those are changes made by core developers. So they usually know what they're doing to some extent. To some extent. All right, so there could be a risky feature branch, like the one, sort of the more extensive changes you mentioned. Yeah, it starts off, and then yeah, some commits, and at some point it's considered to be ready for testing, so it goes into next. Yeah. Similarly, during the in main, there might be a bug that has been uncovered by a user. If that gets fixed, it's branched off main, and once that bug fix is applied, it also goes to next for testing. So sort of next is sort of the branch where everything gets jumbled together, and if things are okay, then they get disentangled again in some sense. Okay, yeah, so the bug fix goes back to master, goes back to main, and in the meantime, you can just start another feature branch, and so the branches develop. And what may happen is here in the risky feature branch, there might be something uncovered that didn't work properly, so you have to retest it. But as soon as your feature branches are in good shape, they get back to master.
Carl, how much of this is automated, like scripts, merging stuff? I mean, obviously, when you start a branch, that's manual. A bug report, that's manual.
Oh, you should have a discussion with Barry about that. Oh, well, with us. It's sort of, that's a workflow issue we're actually discussing right now. So right now, those merges are manual. That means if you consider your feature branch ready, you merge it to next. Or you open up a pull request, and then the integrator takes care of it. Now, if things in next are fine, there is no automated process that just dumps things back into master. That is also done manually. And now, sort of that takes extra effort and time. So we are constantly discussing ways of sort of improving that process so that there is a mechanism that in the background just sort of, you tag your feature branches being ready, and then the sort of the script takes care of merging to next, checking whether next is fine, and if next is fine, it merges it back to master.
Currently, Satish is doing that step a lot now.
Yeah, but it's not fully
Not
automated.
comparing Satish to a script.
Yeah, but Satish, he had a problem with Next getting so clogged up with branches, it would sit in there forever.
Yes.
He decided to be more proactive about, okay, Richard put a branch in, it passed, and then oftentimes now before I even go get a chance to merge it into master, Satish has already done it because he saw that it passed. He was trying to keep it clean, but yet this is not scalable in Satish's.
Right.
So we need a better long-term solution.
Did I understand correctly, you say you find a bug fix in maintenance, do the bug fix, test it, and then merge it into maintenance?
Yes.
But how do you know that what you tested in test is actually what is in maintenance with the bug fix?
No.
Why don't you test it on your bug fix branch? Do the bug fix test?
Well, your bug fix branch is merged as a whole into next, so it's sort of.
Your bug fix branch, you'd have to do your testing there and decide, yes, that's a good bug fix.
Oh, okay, yeah, that might
then
be.
It goes back into maintenance and goes into master.
That's completely legitimate what you just said.
Yeah.
What we do is we do run the entire test suite on the maintenance branch twice a week. Just because of time limitations. We could potentially run it every day, and then it would do essentially the two.
When you do your bug fix on maintenance, it looks all okay with the front of that. It's all we do, open for another bug fix somewhere else.
Yeah, that's possible. I've got to admit, we've never really seen that, but it's certainly possible.
Yeah, so the process is not watertight for that case, but at least it catches most of the issues. So.
Can I suggest you continue that conversation over coffee, because
Yep.
we are now in the break. All that.
All right, merge with evidence of stability. Yeah, and then basically it's time for the next release, sort of 2.0 or whatever it's called. And now at that point, this is where the big cleanup happens. So old feature branches that are completed, they just get kicked out of the repository. And also next gets deleted and reinitialized from master. All right, so yeah, starting your next from master. And with that, yeah, it's time for the coffee break. I'm just reiterating what we have heard in the tutorials. Yeah, so PETSc can help you, but yeah, keep in mind that you can also help PETSc even though you think something is just a trivial, simple change. Yeah, the code base is large enough so that things don't get noticed by the developers immediately. So even if you just think it's just a tiny little thing, please don't be shy and just open up a pull request. There is even two removed line breaks are not a too simple pull request to merge. All right, thank you.
There is coffee. We have a half-hour break.
And just one comment. One way to get started with a pull request that's even less harmful than this one is noticing things that are wrong with documentation. And going in and changing things in documentation, improving the documentation, which doesn't change the source code or won't break anything. But it's a way that you can make a couple of test runs that make sure you understand the process.
Can you go back one slide? I want to see your last kit app version there.
Oh.
On the previous slide.
This one?
Yeah. Okay.
Yeah.
So, translate get into Esperanto.
Well, it's like the intersection of everything.